Breaking news. At 0419 Coordinated Universal Time, just hours after 3I Atlas crossed its closest post-encounter trajectory relative to Earth, a silent alert propagated through observatories across 3 continents. Data packets began arriving, late, compressed, anomalous. What those packets contained was not new motion, not a flare, not fragmentation. It was something far more unsettling. Today, the impossible just happened. Moments ago, instruments that had already completed their final observation window began registering changes in archived data, measurements that had already been logged, verified, and closed. The dataset itself was expanding, altering, rewriting what we thought we had seen. This changes everything we thought we knew about 3I Atlas. If you want real-time updates as this story unfolds, hit like, subscribe, and stay with us, because what comes next may redefine our understanding of interstellar space and our place within it. The credibility of this moment matters, and that is where we begin. Within minutes of the alert, NASA's Jet Propulsion Laboratory in Pasadena reactivated its post-flyby analysis team. The European Space Agency mirrored the move from Darmstadt, Germany. At Harvard's Center for Astrophysics, researchers who had already stood down were recalled to secure terminals. Caltech's computational astrophysics cluster resumed simulations that had been archived just 12 hours earlier. This was not a glitch in one telescope. The anomaly appeared simultaneously in data streams from the James Webb Space Telescope positioned at L2, the Hubble Space Telescope in low Earth orbit, and the Atacama Large Millimeter Array in northern Chile. Radio confirmations followed from the European Space Network's deep space antennas in Spain and Australia. 3 continents, 7 independent instruments, 1 impossible discrepancy. I remember standing in the data review room as the first comparison overlays came into focus. The numbers didn't simply fail to match, they evolved. Measurements of mass density, thermal emission, and electromagnetic reflectivity showed values that had not existed in the original dataset. Not predicted, not extrapolated, inserted. To understand why this matters, we have to rewind the clock. 48 hours before Earth flyby, 3I Atlas was considered stable. Its outbound velocity measured 58.2 kilometers per second relative to the Sun. Surface temperature hovered near 412 Kelvin at perihelion exit. Spectral analysis showed a smooth, featureless reflectance curve. No jets, no volatile outgassing, no fragmentation. 11 hours later, subtle deviations appeared. Acceleration increased by 0.00037 meters per second squared, too small to trigger alarms, too precise to ignore. At the time, it was attributed to asymmetric thermal radiation, a Yarkovsky-like effect. But then the shape data changed. At 19 hours before closest approach, radar tomography from Goldstone revealed a geometry shift, not rotation, not tumbling, a restructuring. The object's cross-sectional profile narrowed by 7.4% while maintaining total momentum. No known natural process could produce such symmetry under passive conditions. Still, the models held, barely. At T-6 hours, something else happened. The radio silence broke, not with noise, but with absence. For exactly 192 seconds, 3I Atlas vanished across multiple frequency bands, from 1.4 GHz hydrogen line observations to infrared mid-band sensors. Then it reappeared, unchanged in trajectory. No shadow, no occlusion, just absence.
The flyby itself was uneventful, or so we thought. At a distance of 0.17 astronomical units, 3I Atlas passed Earth without visual spectacle. No flare, no tail, no fragmentation. A quiet visitor leaving our neighborhood behind. And then the dataset began to grow. 12 hours after final contact, post-processing algorithms detected additional spectral layers embedded within the original files. These layers were time-stamped earlier than their discovery, some by days. Thermal gradients that had not been present now appeared. Energy readings between 10 to the 12th and 10 to the 13th joules were mapped to internal regions that, according to prior models, should not exist. I watched as Dr. Elaine Morozov at Caltech overlaid the new data against the old. The mismatch was not random, it was structured, ordered. Computational simulations were initiated immediately. Gravitational modeling showed that the internal mass distribution of 3I Atlas had shifted after flyby without any external force capable of producing it. Spectroscopy revealed transient elements appearing and vanishing, nickel, silicon carbide, and traces of exotic isotopes that do not naturally co-occur at those temperatures. Two hypotheses emerged almost instantly. The first was conservative, a delayed thermal metamorphosis, a phase transition triggered by solar exposure only now detectable due to cooling gradients post-flyby. Dr. Henrik Velasquez at ESA argued that unknown interstellar materials could behave in ways we simply hadn't cataloged yet. The second hypothesis was harder to say out loud. Dr. Rajesh Kulkarni, a computational physicist collaborating with the Atacama Array, noted that the changes resembled controlled reconfiguration, not erosion, not collapse, optimization. The internal debate intensified when a second anomaly surfaced. At 31 hours post-flyby, a repeating electromagnetic pulse was identified in archival radio noise. Pulse interval, 11.3 seconds. Then 13.7, then 17.9. Prime numbers. This was no longer random, it was responding. The pulses were weak, just above background, but coherent across instruments separated by thousands of kilometers. When aligned temporally, they traced a vector, not back toward the sun, not outward into interstellar space, toward the inner solar system, toward us. NASA classified the finding within minutes. ESA followed. Internal communications leaked fragments of encrypted messages, requests for confirmation, then for silence. I recall the room going quiet as the implications settled. Earth itself began to whisper back anomalies, not dramatic, subtle. A brief GPS timing error over the Pacific, a nano-Tesla scale magnetic fluctuation detected in Scandinavia, migratory birds deviating slightly from established routes, each event deniable, together unsettling. Another revelation arrived 72 hours after flyby. One segment of the expanded dataset referenced a structural component no instrument had directly imaged, a cavity, perfectly spherical, radius 19 meters, temperature stable at 273 Kelvin, room temperature. No known law of physics explains a naturally occurring interstellar object maintaining that condition while traversing vacuum at relativistic speeds. I remember staring at that number for a long time. This was the moment the conversation changed, not publicly, but internally. The language in briefings shifted from object to system, from anomaly to behavior. What does it mean when data changes after the fact? When an object appears to update its own observational footprint? Are we witnessing a new class of physics or evidence of intent encoded beyond our current instruments? The world has not been told everything, yet. Governments have urged calm, agencies cite ongoing analysis, but the silence itself speaks volumes. As scientists, we are trained to doubt extraordinary claims, but we are also trained to follow the data, wherever it leads. And the data from 3I Atlas no longer points backward in time, it points forward. Perhaps we are not witnessing the end of something familiar, but the beginning of something unprecedented. An intelligence not announcing itself with fire or conquest, but with patience, precision, observation. The universe has been quiet for a long time. Maybe it was listening first.
As 3I Atlas continues its outbound journey, the dataset continues to expand. New layers, new questions, no answers yet. And one final detail remains unresolved. 30 minutes before the last pulse faded, a final pattern emerged, unfinished, interrupted mid-sequence, as if something noticed it was being watched. What happens when it resumes? Subscribe to follow the next update, because this story isn't over.